Here it is. It's, July 2021, all right? So if you're looking for it, that's where it is. So that's the one thing is get enough people on the article and we'll make sure we get it right here. All right. It's not lying if you show it all. There's no coincidence there's 5 people up there and there was 5 authors. So that's just happened randomly. But we had 3 different groups of people have said, and we provided the data in these tables in the ACI article. So you can go and grab the data and do to your heart's content what you'd like. Notice that as Tim showed you, we tried to say what the equipment was used at the bottom and what equipment was used at the top. So that way, if we could correlate sometime with something that happens there, we might have an opportunity. Here's the one for the slope paving, slope broom, and then the warped one. We didn't have as many samples on the warped one. Jim Cornell showed you some data earlier. It matches pretty close with his data. And here's a summary of it. How many measurements, what the thicknesses were, standard deviations and averages. When you get data, the first thing you do is you want to compare to other data. What other stuff is out there? Because are we in the ball game or are we totally off base? And so we compared to some other stuff. Tip showed you the Augusta Faro data, that's in table 9 there. So we looked at that. Jim Cornell presented some data earlier. He had presented to 117, and we looked at his data too to find out. And so it looked like we were in the right ballpark, but we wanted to check some data from the highway departments. And this is an interesting one because notice that the thickness is 250. That's what's specified. And what was placed is about 265. That's not unusual for pavements and highway departments because those highway departments have what? A pay penalty. They take money out of your hide if you have something low. Our problem is okay, if 250 is the minimum, we have a pay penalty, we can get you there. You have to be willing to pay for an extra ½ inch. So we have contractors that are saying, when they say the word minimum, we go in there, you want minimum 6 inches? All right, well, we're going to have to average 6 3/4. So you got to pay for an extra 3/4. And then everybody says no. So they want a minimum thickness, but they want the average thickness at the same line. That's never really going to work. Notice on the points, the scatter of the points, we'll look at what we've got here. Their standard deviations aren't much different than ours in parking lots. It's the same variability of workmanship. The difference is they get paid for an extra ½ inch or 3/4 inch of concrete. And everybody's willing to bid it that way. And the owners, our tax dollars, are willing to accept it that way. So if we're willing to do that on parking lots, great. But we can't find owners that are willing to pay for it. So that's where our issue comes in. And so we're matching what is being done out there. So this is just a summary of the 3 different sections there. How we decided to now analyze it. So this is one of our problems. And I already talked about volunteer, convenience, and random sampling. And here's the random participants. And that's when you know you're in trouble, when you got, volunteer sampling from the group. All right, so this is what we thought was happening here. We thought we were receiving information, fair, good, very good, excellent. All right. And now I'm sitting there going, how are we going to analyze this mess? And so there was one opportunity that sits out there that I know in an ACI document that has excellent, very good, good, fair, and poor, right? And so it was like the light kind of came on and said, well, we need to go ahead and follow ACI 214 approach. ACI 214 in their testing and analysis has the categories of excellent, very good, good, fair, and poor. So it seemed like it would be better to try and group those categories as to what that might mean than to try and take a full statistical approach and then go ahead and throw it out there and say, all right, everybody that's doing slab on ground must meet what all these contractors of ACI 330 that are on 117, 302, all these guys have been doing 20 or 30 years. That didn't seem quite right. Now, having said that, as I told you earlier, ASCC has bought an impact echo to start testing others. All right. They don't have to be members of ACI 117 or ACI 302 or ACI 330. We're not sure that we've collected all the data that we need. But what we did was put out the data that we had and put out the rationale for where we went. And as we collect more, hopefully a year from now, when we have, let's say, 50 more projects and 5,000 data points, we can come here and say, we need to tweak this to the left or to the right. And here's the group we have. Will we have a random sample again? Now we're probably going to have volunteer samples, because if you're a member of ASCC, you call up and say, ship me the impact echo, you get it. I don't know, that's not random, is it? And they're going to pick a project that's probably not random. So it's not that these issues are going to go away, but they have been done a lot of times. Education. My daughter's getting her PhD in special education, and she's taken 5 or 6 statistics courses. So I've been looking at them, and in education, they do volunteer sampling all the time. They call up a school and, hey, we need a database. What's this? And 6 teachers raise their hand. We'll go ahead and provide data. Those 6 teachers, were they chosen randomly? Nope. They were volunteered. And what are they choosing for their classrooms? And so it does sit out there as a group of science. You just don't get it in too many engineering books. So we went this way with excellent, very good, good, fair, and poor. And then we went with choices as to what we think might work. Jim Cornell mentioned that earlier. This was presented to ACI 330 on a Zoom webinar. Some of it's being balloted. There's some, what do I want to say? There's some that voted affirmative, and some have voted with affirmative with comment, and some voted negative. Shocked in the ACI world. So ACI 117 is addressing these comments now, and we'll see where it's going. And I think this is the next slide, as a follow-up to this, ACI 330 just had a vote a few weeks back, maybe a month back. They're coming up with the new specification. They voted in ACI 330 in their new specification that will go to TAC and then obviously out for public review. They voted to use the tolerances in ACI 117 as they exist, because the point was, you can't go ahead and reference a future ACI document that doesn't exist. So we will see from ACI 330 on their specification, we will see the information that was in 2006, 2010 that was reapproved in 2015. Now, it still has to go out to TAC and public comment, and we could make a public comment maybe at that time if 117 has balloted and gone through the same process. So we're stuck a little bit. My comment to 330 was, go ahead and put in what you want to put in. I don't think you want to go ahead. We're going to have to live with these tolerances for the next 10 years until you come up with a new 330 specification and can reference the new ACI 117 that's coming up. So everybody should recognize that the way we're heading down the future is we're repeating the past. That's it. Eldon.
Yeah, I have one quick comment about the excellent, very good, good, fair, and poor. If designers are going to be choosing which of those tolerances or standard deviations apply, they're going to have a hard time explaining to their owners why excellent is not what should be used for their project.
Yes, so we used excellent, very good, good, fair, and poor, but when we recommended tolerances, you might not be surprised that we did not base them off excellent. They're not based off excellent, very good, or good. It looked like what ACI 214 was willing to accept as fair, so we based them off that. So we're saying we're choosing the fair column out of what we consider to be industry experts.
Good point. Thank you.
However, yeah, we do not want somebody, if you want to choose the standard deviation for excellence, we're talking about a very minimal group who will get you there. And they won't get you there every time either.
Thanks, Bruce.